Hi everybody, I'm Dr. Valentin Voroshilov. In a minute I'm going to tell you a little bit more about myself, but first, this is a pre-recorded lecture. You know, when we involve technologies, something happens. In case, due to whatever reason, we will not be able to hold our first live lecture, I decided to pre-record the introductory lecture. It will be shorter than the actual lecture because the actual lecture also would involve the time for your work in groups and answering questions. Of course, that's not going to happen now because no one's watching. So this would have been my first question to you. How many yellow dots did you see on a previous slide? I will use this time to collect your responses and to talk about myself. As you can hear, English is not my native language. I have an accent, and especially now, after a long break, I need to really learn how to speak English. My brain has forgotten how to do that. I grew up in Russia, got my education in Russia, then I moved here. I've been teaching physics and other subjects for a long time. This slide tells you, do not read this slide. What does it mean? Of course you could read it, no problem. Let your eyes wandering across the slides, but these slides are not designed for you to read them now. These slides, all of them, designed for me, so I wouldn't miss something important. And if I switch to the next slide and you didn't read everything which was on a slide, that's fine. Don't worry about that. First, all lectures will be recorded and you could watch them again. Plus the slides, all notes will be posted on our course site, Blackboard. And I also have some slides specifically designed not to be read in the classroom. Those are like pages for an electronic textbook I'm preparing for you, so you wouldn't have to read any other textbook as well. I know my name is rather complicated, that's why I've shrunk it to a very simple and short nickname, Mr. V. This is how you could address to me, and this is how I will be signing my emails to you. Well, this is time to check your answers. 2 yellow dots you would see on the very first slide because those are eyes of the smiley face. You would wonder, why would I ask a question like that? Maybe in the future we'll talk about it. It's a very well established fact that different students have different learning styles and different instructors have different teaching styles. Well, most of the time, these slides, you see, my brain is still warming up. And unfortunately, in the past, I had COVID, and there is some study that essentially says COVID makes people stupid. So this is kind of an experiment, how much more, stupid I've become. Learning styles, teaching styles, if they represent a good match, learning and teaching process usually goes very smoothly, but it's not always the case. So if something is really gets in your way of learning, require some extra help. Let's hold office hours, let's communicate more. We can find many past reviews on the internet. I'm in Google, you're in Google, everybody now is in Google. And if you check the reviews from the past, you will see that I have positive and negative reviews, which is absolutely natural because, no one is perfect. The good thing is, even though for every positive review I have opposite negative, for every negative I have opposite positive, the total amount of positive reviews is larger than negative. That's why I keep teaching. This is not an online course. Online would have been you could watch lectures pre-recorded and do homework and labs anytime you want. All the material would have been posted on the internet, and you could study that material whenever you want. That's not the case. This is basically the same old-fashioned on-campus face-to-face course with only one exception. Geographical location is different for different people. We're not in the same room. So that's why we call it a remote course. And for a remote course, we have to use specific tools like Zoom. Zoom is a requirement, and we will use it for lectures, labs. I don't have a special day or time established for office hours. You need help, just send me an email. I will send you an email back. If the question requires more general answer, we could schedule a face-to-face meeting. In that case, I would announce the day and the time for this meeting to everybody so anyone else could join, and usually it is sufficient. You will need to use Slack for your labs. The vast majority of the time, you will be spending working in breakout rooms, and Zoom doesn't provide good, efficient communication tool for that period of work. Slack is better. Slack allows send pictures. Slack allows sending longer messages. So you should go to Blackboard, find the lab syllabus, and follow the instructions how to install Slack for your specific lab section. Plus, you will need to download and install 2 additional programs. All course material will be uploaded to our course site, Blackboard. If you go right now, you can see already there's a homework number 1 there. There's a grade column. Ignore that. I haven't posted any grades yet. So whatever grades you see, those are fake grades. Blackboard has an internal built-in grade column which cannot be deleted. So just ignore that. When you log into Blackboard, you wouldn't see anything first. You should click course content and then you will find everything, including the syllabus. Your first homework would have been just reading the syllabus. I'm not going to go through page by page. You should check it and you will find the schedule, the grades, a calculation procedure, even a free textbook, which technically you may never use. Why do we need to study physics? Well, my strong opinion is everyone needs to study physics, because nowadays you can find it anywhere. It's not just physics. You will find physics in chemistry, biology, economics, even sports. So it's very important to learn at least the basics. Plus, physics is I would say, the greatest tool to boost our reasoning abilities. Unfortunately, too often physics is being taught in a wrong way, just as a combination of disconnected facts. That doesn't help to boost our reasoning ability. I'll try to represent you internal logic, which will help you to analyze any problem in physics and in general any problem in life. Well, this would have been another general question to you. How do you feel about yourself? Are you good at physics? Are you bad at it? And I would ask you to give me a response from 1 to 9. If you feel you're very bad, you would choose 1. If you feel you're very good, you would choose 9. But based on my experience, people don't really like making strong assessments about themselves. So I would expect maybe 1 or 2 students would choose 1 or 2, 1 or 2 would choose 9, but very often no one does that. 4, 5, 6 usually the best safe choice. So the distribution would look something like that usually, which is absolutely natural. But the thing is, it doesn't really matter what we feel about us, especially when we study natural science, especially physics. When we study natural science, feelings don't matter. We cannot rely on our feelings. Often our feelings lie to us. We only can rely on facts. So it actually doesn't really matter what you feel now. And if you don't feel good now, I can promise you by the end of this course, you will feel better, even if though you still can't rely on that. But that's just a fact. The vast majority of students tend to underestimate the abilities to learn physics. This would have been my last general question. It's not about what you feel about you, it's about what you feel about physics. How would you finish this sentence? Physics is, you could choose complicated, boring, or you could choose a two-word ending like a complicated and fun. Well, again, based on my experience, if you would just start entering this sentence, physics is the most common search in Bing. Is physics homework help, assignment help, or tutoring? So it's not about physics per se, it's about how to study physics. These questions, of course, are related. But when someone tells about physics, what that person thinks, usually I see complicated, boring. Sometimes some students say fun. I don't recall anyone saying simple. By the way, this is a case when among possible answers provided to you, there's a definitely wrong one. No sane person would ever say physics is fun and simple at the same time, because it's not. Even for me, even for people who do physics, sometimes it's really, really tedious and boring. Very often we confuse words with different meanings. Very often when people say complicated, they mean hard, but those are different things. Complicated or complex is a description of a structure of something. If an object or a system has many, many, many different parts with many, many internal connections, that makes the structure of that system complex or complicated. If a system has only a few elements with only a few connections, it's a simple system. And there is a difference between simple and easy, like this example. If you would like to learn how to walk on a rope. That's a very simple situation. You don't have to comprehend a lot to understand what to do. Pole number one, pole number two, rope. Done. Simple. But is it easy? Of course not. Try to walk. It is actually hard. It requires practice. So complicated is not always hard. Simple is not always easy. Plus, actually, if we want to learn how to solve a problem about forces acting on a person standing on a rope, it's much easier than to learn how to walk on the rope. So you should keep things in perspective. Hard, easy. Physics is simple because it has a very transparent structure. And one of my goals is to show that structure to you. But of course, to learn physics requires effort. When something requires a lot of effort, we say hard. Not a lot, we say, well, not so hard. But it's not about physics per se. Again, learning always requires effort. So learning always is hard in a way. It means you need to practice. Practice, well, practice doesn't make perfect because nothing and no one is ever perfect, but practice makes things better. Practice makes progress. And for practice, you have homework assignments, labs are for practicing. So you've got a lot of opportunities to practice. Just use those opportunities and you will go set. So about general logic, as I said, it's very transparent. You see, the most general mental activities every scientist, every physicist goes through when needs to understand something are the same, and not a very large amount, just 7. It doesn't matter if you and I try to solve a problem about a person walking on a rope or Einstein trying to create a general relativity theory. Mental steps are the same. We have to think about something. It's very important to be able to imagine things we are thinking about. Equally important to be able to describe it in words. Only then we could try to apply some mathematical reasoning, sequence of steps, which is being used by everyone in physics when one wants to solve a problem, any problem. When we have specific steps we need to enact, perform, we call this an algorithm. So this is a thinking algorithm. I strongly recommend everyone to have a copy of this slide, just print it out and have it with you in front of your eyes every time when you need to solve any problem in physics. Homework problem, lab assignment, doesn't really matter, because this is what I'm doing in my mind when I need to solve a problem. I'm asking these questions to myself, searching for the answers, and gradually, step by step, I get to the solution. And you can do the same. And by the way, these are the examples of the slides that you're definitely not supposed to be able to read off a screen. These are the slides which represent pages from that electronic textbook that will be posted on Blackboard. Those slides are usually marked with number like this at the right top corner. 1, 2, 3. If I see a number like that, I know I definitely don't have to go through all the details. And if you see a number like that, you know that too now. So what does this picture tell you? Well, there's another common misconception that you cannot succeed in physics if you are not very good at mathematics. That's wrong. Of course, we will use a certain mathematics, but very simple, very rudimentary, and it's not the most important skill people need to have to succeed in physics course. Reading and being able to write in sentences is actually much more important, but even more important is being able to imagine things. Why? Well, physics is a natural science. It is based on experiment, and we have simply no time, no resources, no equipment to do all experiments which have been used to build physics as a science. So instead of doing all those experiments, we have to do mental experiments, and for that we have to be able to use our imagination. So imagination, mathematics, what's next? When we learn, we make mistakes. That's natural. It's impossible to learn something immediately. So we have to make a mistake and try again, make a mistake and try again. Making mistakes is actually a very good thing. That's the only way to learn. We learn only from mistake. And mistakes are inevitable, unavoidable, and don't feel bad if you made a mistake. Feel actually good about it. It gives you an opportunity to learn. And of course, it's very helpful to work together with someone. So you can form study groups, communicate about homework problems. Even a simple action of speaking it out to someone helps you to achieve a better understanding of what the situation is about. Physics is science. The ultimate goal of any science is to make a reliable prediction. So I can take a ruler, measure how high this ball is from the floor, and make a prediction. How much time would it take for this ball to hit the floor? Then I could take stopwatch and check my prediction, and it will be correct. This is what science does. It makes a reliable prediction. If there's a scientific field where we cannot make reliable prediction. That scientific field is not a science. Yes, it's more like a zoology or alchemy. And that's what education is. It's not science. We cannot make a prediction about how much material that particular student will learn by the end of the course and what grade that students will get. But we still know something about learning, something important. For example, we know where learning is happening. Our body has many, many different organs, but learning is not happening in our heart or liver. Learning is happening in our brain. Our brain represents a composition of billions of neurons, and learning is basically making connections between those neurons. The worst way to learn is just staring and listening. In that case, only a very small number of neurons is being activated in our brain. And if we want to learn better, we have to act more. What could we do? Well, we could take note. Even a gesture, a simple gesture, excites an extra neurons and helps you to learn. Well, of course, taking notes doesn't mean writing down every single word you hear. Doesn't make much sense because, as you know, you could rewatch the lecture in full. You could reread all the slides in the future. So what you should writing down is your thought about what you hear or see. If something feels confusing, this is where you should act and write down, okay, I should figure out it later. Plus, when we're imagining things, drawing pictures is very helpful. You should do that. No, of course, solving an actual problem requires writing equations, using a calculator. You should do all that. If you don't do that, you will become a less efficient learner. That's it. An ultimate goal of this course is, of course, to provide you with a deep understanding of fundamentals of physics. But the practical goal, of course, is succeed on exams. We're going to have 3 regular exams and a final exam, and every exam will be composed of several problems, maybe 5, maybe 6, maybe 7. So you will be solving problems. The good thing is none of those problems will be absolutely new. We'll have 3 sources of problems for exams, lectures, homework, lab. So every exam problem will be similar to something you've seen before the exam. All you need to train yourself is to be able to recognize what you've seen before and then reapply the same way of thinking, the same strategy to a very similar problem on the exam. This is why having this set of questions is very helpful, because if you by any reason can't recognize a problem, but if you will start asking these questions one after another to yourself, eventually it will click in your mind, oh yeah, I've seen that before, I've done that before, and then you can reapply the strategy. All exams will take place during the lecture time. About 5 minutes before 11, I'm going to upload the PDF file with the exam on Blackboard, and you will be able to open it and use your own paper for solving all the problems. Then, when you're done, you would take your smartphone and you would take pictures of your work and email it to me. So we should zoom in around 11, like it would have been a regular lecture, and for about 30 minutes after the lecture, I would be waiting for your pictures. It would take time to take a picture, send it to me. So I would suggest you should practice so it wouldn't take too much time, because sometimes after the exam, we will have our regular lab, and the break between the lecture and the lab is 15 minutes. So ideally, you should be able to send your work to me before the lab begins. Well, we'll see how it works. If you have any questions, you can send me an email and I will answer those questions. And we're done with this general introduction.